Hello friends, so here is another question on complex exponential signal. So here we have to check whether the signal j e to the power g6t, it is periodic or not, and if it is, what is its fundamental period, the value of the fundamental period. Okay, so again the basic requirement of a periodic signal is this: it should repeat itself after a particular interval of time, which is the fundamental period capital T. Here xt is equal to j e to the power j6t. X, this is, let's say, equation 1, xt plus capital T, that is equal to j e to the power j 6 t plus t, this. Okay, this much, or we can write it as j e to the power j 6 t into e to the power j 6 capital T. Okay, this is expression 2. Now for this requirement to be satisfied, these two expressions must be equal. Okay, these two expressions, and that is only possible when the value of this much part, okay, e to the power j 6 capital T, that is equal to 1. Okay, so e to the power j 6 t, we can write it as cos 6t plus j sin 6t. Okay, this much should be equal to 1. So it is possible when this value 6t, that is equal to even multiple of pi. Okay, that implies t is equal to 2n pi by 6, or it is equal to n pi by 3 seconds, the general expression of the period. Now for the smallest possible value, that is n equals to 1, the fundamental period is equal to pi by 3 seconds. This. So yes, the above signal j to the power j6t, it is periodic, and the fundamental period is pi by 3 seconds, the smallest value of the period after interval after which it repeats itself, and the general expression is n pi by 3 seconds. Okay. Hello friends, so we'll continue our discussion related to periodic and non-periodic signals. So in this video we are going to discuss some questions related to sinusoidal signals. So here it has been asked to show that the sinusoidal signal with the general expression equal to xt equals to sine omega 0 omega subscript ot plus theta is periodic with the fundamental period equals to 2 pi by omega subscript o, where omega subscript o is the angular frequency. Okay, so the basic requirement of periodic signal, okay, is that it repeat itself after a fixed interval of time, which is called as the time period, or the smallest possible time period is called as the fundamental period. So here xt is equal to sine omega 0 t or omega ot plus theta. Okay, x t plus capital T, that is equal to sine omega subscript O t plus t plus theta, okay, which is equal to sine omega subscript t. So omega O small t plus omega subscript O capital T plus theta, or we can rearrange it and write it as sine omega subscript O, or whatever you want to call it, small t plus theta plus omega subscript O capital T, this form, okay. Let this be equation 1, let this be equation 2. So to satisfy this requirement of periodicity of signals, these two equations or expressions must be equal, okay, and that is possible only when this portion, okay, omega subscript O capital T, that is equal to even multiple of pi, 2n pi, okay, that. Then we know that sine 2 pi plus any angle, acute angle which is there, that is equal to plus sine theta, okay. So here, to avoid confusion, let us call it phi, okay, will be equal to phi, this. So when this one will be 2n pi, with n equals to 1, if we put it, it will be 2 pi, 2 pi plus this much, it will be equal to sine omega subscript O t plus theta. So omega 0 t is equal to 2n pi, that implies capital T is equal to 2n pi by omega subscript O, that implies for n equals to 1, the smallest possible period, the fundamental period is equal to 2 pi by omega subscript O, this, okay. So here we have proved that this sinusoidal signal is periodic with the fundamental time period equals to 2 pi by omega subscript O, okay.